Hello, everybody, and welcome back once again to a weekly show that we run called Databases for AI here at AWS. If you haven't joined us before, let me know what you just tuned. I'll let you know what you just tuned into. This is a show where every week we deep dive into the very hot space of AI, and we show you different techniques for how you can improve your AI applications built on top of database primitives. In this case, a database primitive from AWS. So really excited for today's show. If we haven't met before, my name is Trevor Spires. I am a solutions architect here at AWS, and I am joined by the wonderful, the great and powerful Siva. Siva, would you please introduce yourself to the folks that have tuned in today?
Thanks for the energetic introduction. Yeah, my name is Siva. I'm a specialist SA here in AWS. I do Elasticache, MemoryDB, and everything in between, and Agentic AI and stuff like that. Been with AWS for a little over 4.5 years. Excited to talk to you guys about Agentic AI today, especially memory management.
Love it. Love to hear it. Yeah, it's a super important topic, right? So, like, I guess if you're watching, what you should kind of expect from today's show is, we're gonna obviously talk a little bit about agentic memory. We'll dig more into that into a second. But by the end of the episode, you should have a basic understanding of what do we mean when we say agentic memory. We're gonna dig into short-term versus long-term memory, and you're also gonna have a sense of why this is important, right? And I'm not going to bury the lead. I'll just tell you why this is important right off the bat is LLMs are great at inferring things. They're not so great at remembering things, though. And that's probably a good place to start for us today, Siva, is when, I think folks that are watching, they may have heard of agentic memory before as a concept, but it'd be good to get your take off the bat of kind of where agentic memory fits in and why it's so important to people that are considering building an AI agent.
Absolutely. And a lot of us use chatbots, they're pervasive, they're everywhere. So the last time you used a chatbot, I'm sure you're frustrated because you keep having to repeat yourself all the time, and it's crazy. It doesn't remember most of your preferences. It doesn't remember, what you need. And let's say, you're shopping for your wedding or vacation, and then you have a 30-minute long conversation talking about, okay, this is what I'm planning, this is what I need, and then you had to go pick up your daughter, and you come back, and then your session, again, your browser exited, you create a new browser session, boom, everything is gone. And and that's where agentic AI, where you can actually have short-term and long-term memories tied to your user profiles. It enhances the user experience quite a bit.
Absolutely, yeah. I think I think as in general, if I think about, we work at Amazon, so I think a good example to think about for us is always like an e-commerce application. If I'm chatting with a bot or a service that runs on an e-commerce website, I kind of expect that application to have understanding of like, what are the things that I bought previously? What are the questions that I asked previously? We were talking about a use case the other day, Siva, where it's like you might want to be able to go in and say, like, I'm planning a vacation and I need to buy some things, and maybe to your point, you step away and you need to come back the next day, and you don't want to have to constantly re-prompt and re-explain and re-copy and paste in all your context. The expectation these days from customers is that the agents that you expose to them do have some context and memory so they can personalize their recommendations. So I think that's a pretty good, like, high level overview for folks. And for folks that are in the chat, by the way, one thing I forgot to do today is let you all know I'm dialing in from the great state of Maine, and I always love seeing where our guests are dialing in from. Looks like we've got folks from a few different spots here today. Where are you coming at from in the world today, Silla?
I am from the great state of Texas.
The best state, right? That's what I hear. That's what I hear from you Texans. It is the
Lone
best
Star
state.
Yes, that's right.
Amazing. If you're joining us, two things, right? Let us know where you're coming in from. We love to know where folks are joining us from before we dig into the technology. And of course, this is a live show, so that means if you were to say something in the chat like hi, I'm from Brazil, like our friend just did, or maybe you have a question along the way for Siva, as it relates to agentic memory. That's why we do these live. We'd love to field your questions. So don't be shy. Let us know if you have anything you'd like to dig into throughout today's show. I think Siva, I'm thinking. I know we have some PowerPoint we want to show. Before we do that, I want to pull up an architecture, and I want to get your take on it because
Yeah.
I feel like from a technical. And by the way, if you're not an engineer and you're not an architect and you're tuning in, that's okay. We're going to walk you through at a
Yeah.
system level, kind of how agentic memory would work. So I'm going to go ahead and pull up. This is a great, for me, a really great diagram from a blog actually that we'll post this blog in the chat soon. I would definitely encourage folks to check this out after today's stream. It's basically a blog that walks you through how to do a lot of what we're doing today. How to implement agentic memory for your own application with something like Elasticache or Valkey. So before we get into the kind of how in the slides, let's talk over this for a second, right? Of kind of like the building blocks, especially for those people that maybe are experimenting with agentic SDKs, so they can understand some of the terminology and the things that we're going to walk them through today.
Absolutely. So essentially, whenever you're building any agent-based applications, the central to that is the strands framework, right? That's where you use to orchestrate any of your applications, creating agents, whether it's agent talking to an agent or agent talking to an application. Strands is the central theme. And then we have our Bedrock, Amazon Bedrock, which is where you can select, pick and choose your model of your choice. And then strands can interact with it. And now the main piece that we're going to talk today about is Mem0 framework, which is where the short-term memory, long-term memory, how to manage that memory, and how do you actually interact with uh, Elasticache, because Elasticache is a database that we're going to use to store and retrieve memories. So essentially, strands, you have a agent platform, and which is basically your shopping cart. Whatever you build a shopping cart, you have an interface where you can actually chat. Now, within that framework, now we have Mem0, which is sitting between that and the databases. And Mem0 is responsible for basically storing and retrieving all your memories.
Absolutely,
So think of memory as every little thing that when you're interacting using a chatbot, hey, I'm looking for running shoes, or I'm wearing size 10.5. All those things are in pieces of information that you actually would want to store because you don't want to be repeating yourself all the time.
Absolutely, yeah. And one thing I would say to folks here is like what's like we're showing you an architecture really built on AWS services in today's show. But what's really interesting, if you all are building agents yourself, you may be using Strands, which by the way, strongly recommend. Strands is one of the easiest ways to get an agent up and running. But you may also have heard of frameworks like LangChain, Langsmith. There's a suite of agentic frameworks, and plus one to what Steve was saying, Mem0 is this really popular framework, if you will, or it kind of plugs into these agentic frameworks to provide a nice developer experience that you can wrap these memory services in. So, for example, I'm one of the many techies who have spent the last couple of weeks experimenting with the open source project known as OpenClaw, and I set up Mem0 for my OpenClaw deployment to be able to remember all the context of the conversations that we've had, right? And so I want to set that context for folks so they understand, if you're looking to learn this topic, Mem0 is a really strong standard across the industry. And of course, if you're an Amazon customer or you work with the AWS teams already in your day job, we have a full stack of solutions that help you build out the agentic memory, but also even the underlying agentic orchestration that you would need to deliver on your AI use case. Anything else that you would You think is worth
Yeah.
highlighting on this, Siva?
Yeah. Nowadays, most databases come up with their vector search capabilities, right? Sometimes depending upon which database you choose, which solution you choose, it's really difficult to kind of like manage your vector embeddings, doing the retrievals, doing semantic search. Mem0 framework is the right framework because it abstracts out pretty much everything, and then you just run a bunch of API calls around it, and it simplifies all that management for you. With that said, I guess we can get started. The way I would
Yeah.
like to start this is, you know, talked about why actually, what is the problem that we are trying to solve here, right? And then the solution comes about the architecture of how we built how to build a short-term and long-term memory, and then walk you through different examples of how to actually do that.
Awesome.
Okay.
Yeah, makes sense. By the way, actually, one other thing we should probably take 1 second to mention, and I bet you'll be happy to mention this one, Siva. I've got it behind me. Maybe you could answer the question because we're going to be talking about Valkey as a service that we are building agentic memory on top of. Maybe give people your elevator pitch of Valkey for those who haven't heard about it before.
For those who are not familiar with Valkey, it is a highly popular open source key value store, which it's a fork of Redis, drop in replacement of Redis, open source. It is also supported by our services, Elasticache and MemoryDB. And it's we have launched 8.2, and short to be, we are going to launch 9. But it's very performant, highly popular with the open source community. It's a key value store and has all the features that you have used to with Redis open source.
Absolutely. A really awesome option if you need low latency memory for your agents. And it just so happens, one of the reasons Valkey is really popular with customers and the open source community is it's got a really great cost profile for a service like this as well. A lot of customers I've seen using other similar solutions have been migrating to Valkey just because they can get a general lower cost of ownership. So yeah, back to you, Siva.
This goes back to our first conversation about, okay, we all use chatbots, they suck. They don't remember us, what we're chatting about. And an example here is, okay, you're looking for running shoes, size 10.5. I apparently have the same example here too. And then you come back, your browser you got killed, you went to drop your daughter, you come back, and then show me more shoes. And then it's going to ask you exactly what you don't want to hear, which is what size do you want to wear? And this is frustrating for a lot of users, right? This is the problem statement.
100%. And I'll even add, like, this is a very simple example too, right? Like this is something that, maybe you could provide your shoe size again, but like when you are using an app, if you're a daily user of an application, you want it to remember a lot. You want it to remember a lot of the conversations that you've had, right? So yeah, I just want to +1 to that. This can be a really frustrating user experience.
It's a frustrating user experience, and thankfully we have solutions for it. And if you look at what we're going to do here is, okay, how can we enable the agents so that they can remember our conversations, remember our past interactions. And this is where we're going to look at short-term and long-term memory, right? Imagine that you're interacting with your chatbot of your choice, and then you're giving in all your preferences, and every single interaction it remembers. It can remember short-term, which is basically at the session level, or it can remember long-term, which is basically, it gets stuck to your user profile, and it can remember. You come back after a week, it will still remember what your profile is. So next time when you have a chatbot with these capabilities, you don't have to repeat yourself, and you're going to have a much better experience.
Absolutely. And just as a reminder, I see some folks are just starting to tune in. First of all, this is live. Ask you questions in the chat if you have any questions along the way. But this is the solution we're going to walk you through today. You should leave with a really good understanding of how you would implement something like this to improve your agent or your application, leveraging Valkey and something like Mem0. Now, this is the interesting part for me, Siva, especially as a builder. I've always been a little confused about short-term and long-term memory, and maybe you can just walk folks through, the high level and importance of having each of these in your app.
Yes. Short-term memory is limited to you open a chat session and you're talking, you're conversing. Um, it sometimes what happens is 15 minutes into the conversation, um, you have asked so many questions, you don't remember, some of the things, minute details, and you want to recall. Okay, what did I remind me what I actually talked about? Was I looking for lightweight shoes, or why I need more cushion? Then it'll help you recall, what you actually talked within that scope of your session, right? It'll also say, okay, I added something in the cart. Remind me what I added like an hour ago, if the session is still open. So short-term conversations are short-term memory basically stores um, information related to that session, which can be leveraged, during a conversation. Now, long-term memory is now it goes beyond sessions. Okay, you're planning for your vacation. I'm going to go back to the same example. Vacation planning is not easy. You plan multiple things, and you go back, you come back. You want your information to persist beyond sessions. So it has to basically somehow associate data points to your user. So you authenticate, you have a chatbot, whatever you have, um, Amazon or whatever your e-commerce application. You log in and you start having your conversation. So this information has to be actually scoped and preserved at the user level. Now, what kind of information? So it's specifically your preferences. When you specifically say that, okay, I have to have lightweight shoes, or I need to have neutral colors. My budget is just $200. So those are specific things that you want it to be remembered beyond, right? So that is basically long-term memory.
That makes a lot of sense. And one thing one great thing I bet about building something like this on Amazon is I bet as a builder, you have a lot of control over what you want to remember, right? Because if you sell shoes, of course, you want to remember people's shoe size. You want to remember the styles that they like, of course, but
Yeah.
there's such a range of applications and memory, the ability to really be specific about what you remember and what's important based on your app. I feel like, it makes this really valuable for customers that are looking to build something like this with Amazon.
I agree.
Oh, speaking of, we've got a classification logic. I'm getting ahead of myself. Why don't you tell folks more about that?
Yeah, exactly. So I was about to say, it's there right in the next slide. So you have control. There are certain things that are pretty obvious, like when we talked about your personal preferences. Those generally are tagged to long term. But you get the flexibility when you're building the app to kind of like say, okay, you can create a rules engine, and that says, okay, these are some of the things that I want to tag as short term, and these are certain things that I want to tag as long term. But you don't want it to be, you don't want some of the things to go long term. One of the things that we have to specifically focus on is categories. You don't want to mix and match. So as part of this logic is categories. For example, shoes will come under I don't know, a shoes category. Apparel, for example, you're buying a jacket, that comes under apparel category. You also want to make sure that you categorize this data, because at some point when you're having wide variety of data points, it can get really, really bad, especially when you're retrieving these memories back to the user. So examples, right? Shoe sizes, budgets, those are all long term, like I mentioned. And then you start conversing with the chatbot, and you just say, show me more. So show me more requires some context, right? Show me more means many things. So show me more means right now you're talking about shoes. Maybe an hour later you may be talking about jackets. So those are the minute details that you can save as short-term memory.
Yeah, that makes a lot of sense. It's like the difference between actually like saving user preferences and context and things you can remember about the user to personalize the experience, along with I'm almost thinking of short-term memory, at least in this context, as like remembering intent from the current session. I'm picking up what you're putting down. See if I'm picking up what you're putting down. Hopefully folks in the audience are too.
Yeah. Now, here's a simple example, right? Show me running shoes. So I just go in and say, show me running shoes. And then the chatbot is going to display a bunch of running shoes and all that. Now, the key detail here is whenever, internally, when you're storing as a memory, short-term memory, this information has to be tagged with your session, because that's what is going to be again used to filter out the memories and then return back the information to you. So short-term memories, the rule of the thumb is short-term memories is session ID, long-term memories is user ID. Just think of it that way. So coming back to this example, it spits out all these different nice looking running shoes. And then somewhere down the line, you're going to say, tell me about the first one. Yeah. So now it has to remember, what it actually sent you and what was the sequence, and then what's the first one, right?
I feel like this is also I bet, this is something that customers care about when it comes to things like, this is the same mechanism you would use to kind of control security between two different customers, right? So because effectively that, in this case, your example of using the customer ID as like a filter or like index to do the lookup on is what allows you to have probably one vector database that has context for many different users, but make sure that you're only showing Trevor's preferences and Siva's preferences.
That is correct. And the other thing is you have to filter out, because over time you may have built up so many memory data points. And tell me about the first one. It should not return you totally unrelated information. So it should tag all your memories with specific user ID, which user ID can be session ID or actual user ID, so that it can give you the relevant information when it's actually doing the semantic search.
Makes sense to me.
The long-term memory. Now, you start conversing, you're chatting, and you're putting in all your preferences. Like I said, like we talked about. Now, in long-term memory, what it does is basically takes all this information and uses your user ID. Now we have the rule book that says, okay, it looks like this has to be long-term memory. The moment it categorizes this as a long-term memory, then it's going to tag the user ID and then send it back to basically store in your vector database, like a vector embedding, right? It goes to Bedrock, creates a vector embedding, and then saves it as a vector in Elasticache, right? So internally that happens. I know we're going to jumping ahead, but that I'm going to walk through the process later on in the later set of slides. So now you gave all your preferences, and then you came back after 2 weeks and you said, I need new running shoes. So it will remember, and as you can see here, it says, now the code here is ST short-term memory, LT long-term memory. So it remembers all the stuff that you told it, 5 memories from week 1. And then it says, okay, you're looking for running shoes. I remember you're looking for lightweight running shoes under 150, and it's just gonna give you all that. So this gives you a better experience overall, right? Versus, having to repeat yourself all over again.
Yeah, I can really see how this enables people that are building agents to provide a much more rich experience. And again, I mean, I love this example that we have of like basically we could call this like an athletics commerce company, right? They might sell shoes, they might sell tents, they might sell outdoor equipment or whatever. I could, if I'm thinking about how this ties back to like the business, I could legitimately see this leading to you selling more things, right? Because you're able to provide that personalized experience. A lot like, I'm guilty of going on Amazon.com and seeing them recommend another product and throwing it in the cart. And I think this is
Yeah,
almost another version, or could enable another version of that with an agentic approach.
absolutely. Now, here's a technical challenge behind it. I know it's all sounds really great and all that. What is a technical challenge? Okay, we give an example of Amazon.com. Millions of users. Now you have to store thousands of memories. Now the speed has to be really, the performance has to be really there, right? Uh, so Elastic Cache as an in-memory key value data store with Valkey is a perfect example where it can scale to gigabytes and terabytes of data at in-memory speed, and searching and getting relevant memories, it takes under 300 milliseconds. So you don't want it to keep searching and giving you a bad experience. The users get frustrated, they just going to leave the chat if you come back after 5 seconds. You want to make sure that it's fast, it's instantaneous whenever you're giving the responses. You don't want it to wait for a number of seconds. The other thing is cost, right? Efficient storage and retrieval at scale. You want to make sure it's cost efficient as well. The memories, millions of users, thousands of memories, it can get quite expensive, if you don't control. So cost is a big factor. Privacy, again, like we talked about, you want to make sure, the data is, restricted. It's basically one user's data cannot be seen by other users. You want to have isolation, and then relevance. So how do we do it? We use vector embeddings, we use semantic caching, and then the most importantly, we use Amazon Elastic Cache.
I'm talking on mute. Geez, Louise. Hey, I was just saying, somebody in the chat had a really good question for you.
Yeah.
So I think it'd be good to get your take on is like,
Yeah.
It's kind of a twofold question, like who and also what determines exactly what gets classified as short and long. I think you touched on this a little bit, but it'd be good to reiterate that for them, especially as they're looking to learn more about just integrating MIM0 with Valkey, like we're talking about.
Yeah. So first question was who decides, right? As a builder, we have the flexibility to kind of like classify which is short term and long term. But there are certain obvious choices that you want to absolutely have it as long term memory. Like I mentioned about user preferences, absolutely. It's an obvious choice because those are certain things. For example, I don't want to be keep repeating, I want shoes 10.5. No, I want this and that. Those are certain things that long term. No, short term, those can also go into short term, and that's not a big deal. But things that are in short term, for example, list out, talk to me more about the first result, right? Those things cannot be going into long term, because long term, if you come back after 2 weeks, hey, tell me about the first one, doesn't make sense, right? So again, we get to define the rules, because as a builder, we define what goes into short term and what goes into long term. And those rules are basically your domain knowledge, what works for that. Again, you have to work backwards from the user experience. What provides the best user experience, and then build off of it. What was the second question, Trevor?
You know what? We got a question in the chat that's a low hanging fruit question, and I'll take this one. It looks like we got somebody tuning in who maybe hasn't heard of Elasticache before, right? And so, just so you know, if you haven't before, think of Elasticache as a service that you can leverage to manage low latency database systems, key value database systems on AWS. So, it as far as the options available, Valkey is probably the option that we talk to customers about most these days. You can also run Memcached and Redis on top of that. Think of it as, it's funny, before AI, Elasticache was actually used as a caching layer, right? I mean, it's still used broadly as a caching layer across the industry. So think of that as, you go to a website, you load an image, you don't want to send that same image a million times, you might cache that at the edge, so that way it can be delivered cheaper, faster, better for customers. And it just so happens that in the world of generative AI, the same properties that you want from something like memory are also the same properties that you would want from something like a cache at a systems level. So definitely check out Elasticache for your vector DB needs if you hadn't had the opportunity to dig into it yet. And I guess, Siva, you're the Elasticache specialist here. So did I do it justice? Would you correct anything I said there?
You did a great job, and you should be doing my job. But um, so Elasticache, people who are coming from a traditional databases, relational databases, they kind of like it's tricky for them to understand how the NoSQL world works. So in NoSQL world, there are so many different flavors. We have key value, we have document, we have wide column store, like Cassandra, so on and so forth. So Elasticache, its engines, if you look at its three engines, Valkey, Redis, and Memcached, they're all basically in-memory key value data stores. So key value is you supply a key, you get a value, you get an object. It's a simple key value store, right? And fundamentally, traditionally, it was used primarily to cache your queries. Databases cannot scale as quickly as NoSQL relational databases. So if you want to improve the performance of your queries, one way to do that is cache them. The second most common use case is session store. So users, user preferences. We have been talking about user preferences. You can store the user preferences. Traditionally, those preferences, the session stores, were stored at the application server level. But then, that has become an anti-pattern now. You want to store that in a centralized remote cache, like an Elasticache, where you can store the user sessions. Because imagine you have a big application server with 10 nodes, and if you restart one node, what happens to the user experience of the users that have the sessions stored in that one node? It becomes a really bad experience for the user. You want to have a fully managed service like Elasticache that can manage the user sessions for you.
Love it. And just so you're not surprised, for the sake of time, I'm going to jump forward a little bit on the PowerPoint. And I think we've got a really nice. This is a lower level diagram, but I think something that we should kind of walk people through, so that way they can have a sense for. We talked a little bit about how you would implement this. I don't think we need to go in live into the details of how you perform vector embeddings and stuff. I think people can check out the blog if they want to learn more about that. But maybe at a high level, you can start walking folks through how a memory system architecture would work for an example like this.
So high level, right? So you build a chatbot. Example of in this example, we have a React. The front end is on React, and the back end, we are using Fast API Python application. Now the framework MEM0, the framework sits in between. So we have used, for example, in this example, we have two models. One using Cloud 4.5 Sonnet. That's the foundational model that's going to basically gets plugged in behind. It's the brain behind your chatbot. We also have an embedding model. We use Amazon Titan Embeddings version 2. That's the embedding model. And I'm going to get to that in a second. Now, what happens when you log in and you enter a chat session, the front end basically takes your messages. And now behind the scenes, what happens is the very first time when you actually enter a message, there are a few things that happen. Now, you can be on a fresh, brand new session, or you're actually conversing, it's been 30 minutes. So whenever you enter a message, the backend takes that and sees, are there any memories associated with what you're asking me? So it's going to do two things. It's going to go and look at, okay, are there any memories associated with this particular session and this particular user? So it's going to go and look up short-term and long-term memories. How does it look up? That's where the MEM0 comes into play, right? The MEM0 is a framework that interacts with Amazon Elasticache, which is basically a vector data. In this case, it's a vector data store, and it has the vector embeddings. So it's going to do a lookup based on the HNS HNSW algorithm. And I'm going to get to that again, the high level. It's going to look up and say, oh, okay, this particular message that you sent me has, you know, 2 short-term memories and then 3 long-term memories. It's going to go and return all of that to you. And it doesn't return everything. It turns that once you get that, it then returns that information to the foundational model. So foundational model takes the message, takes the memories, put them together, and then gives you that context-aware response that you're looking for, right? Because that's where the beauty of this is, right? You have a message, and if you just plug that message directly to an LLM without any memories, it's going to keep asking you. It's going to play dumb. What we are doing here is, okay, before the LLM responds to your message, we're going to see, store memories, retrieve memories, and plug those memories to the message and send them to the LLM. Now the LLM has context. So we are creating the context for the LLM, and then LLM will better respond to your queries.
Amazing. Yeah, thank you for that overview. That actually makes a lot. The big question mark in my mind was, precisely, what is responsible for determining like short term versus long term, and your explanation of how MIM zero kind of fits into this really helps me, I think, wrap my head around how this works. Hey, we got a couple of more really interesting questions from the chat. I want to get your take on. This one is I can tell we got engineers in the chat today because the people are asking questions that engineers would ask. Somebody asked, how do you think about the size of something like this? Like, is there, I guess there's a world where if this is in production running for a long time, maybe you really fill up that. Is there, how would you manage something like that if a customer had a lot of data getting stored in Valkey?
Yeah, absolutely. And actually, I know this. If you go to the very last slide of this deck, we have the exact same question.
Oh, perfect, perfect.
All engineers think alike. So so just to answer that question, right? Elastic Cache can store a lot of data. You can store millions and millions of data points, and you can actually size the clusters to store millions and millions of data points. Now, vector embeddings, vector store, we have vector embeddings. They're all stored as caches and then indexed. You can size the clusters accordingly. Initially, we had some limitations about sizings, but now that's gone. With Elastic Cache, you can scale your cluster, add more shards as your data grows, and that's not a problem.
Got it. Yeah, that makes perfect sense. So you can scale at the DB level. You can scale it, and I'm sure there's probably some aspect of like cleaning up old memories for certain instances, and I'm sure that can all be orchestrated on top of something like this. Here's another question. I think I know the answer, but I want to hear what you think to see if I've got it right. By the way, great username, Crispy Pro. Crispy Pro asks, why would you use something like this versus like an MCP? I think it's an interesting question for somebody that's exploring MCPs. I know MCPs are pretty popular, but yeah, what's your thought on that one, Siva?
So MCP, you take your first shot, and then I will.
Okay, respond. All right. I will tell you what I think it is. So the reason I feel like an MCP wouldn't make sense for this use case is if you think about what an MCP does, it is it's pulling context into a model in a kind of automated fashion. But I think fundamentally, to deliver a memory service, you need some mechanism, some pipeline to constantly be taking the context of the conversation and loading it into a system, right? So while, of course, I guess in theory, you could take conversation history, load it into like a structured or semi-structured database, and then use an MCP to query that. I feel like and our producers helping us out, by the way, if you're not familiar, MCP is Model Context Protocol, something that if you're an AI builder, you need to know about. But back to why I feel for memory specifically, something like Memcache is a better fit is, that's a system that's really designed to have memory loaded in a way that it can actually be queried effectively, semantically, with something like MIM0. So that's my thought, but I don't know. What's your take?
The keyword is real time, and the keyword is user specific.
Yes, that's a good point.
Yeah. So it has to be real time. When you're creating these memories, it is basically it has to be specific in the context of that particular user that you're talking to or interacting with the chatbot or any application. MCPs are great; they can do, but what happens is you have MCP servers and you have domain knowledge, and they can do certain things, but it is not like in real time, as in they cannot in real time specific to that question they can store and retrieve memories. So that's the fundamental difference.
I love it. I love it. I love it. Hey, folks, if you're tuning in late, just so you know, this is a weekly show that we run every week. So if you want to see something like this again, come back to the same time, same place next Thursday. I won't break the news here, but it's an exciting show next week as well. And we got about 10 minutes left. So if folks have any extra questions, a little less than 10 minutes, make sure to throw them in the chat, and we'll make sure to try to take care of any interesting questions you all throw our way over the next few minutes. And yeah, okay. So Cod agrees. He said, yeah, by the time MCP gets that, like the context is probably changed. Oh, we've got Leon. He said he's coming back next week. Thank you, Leon. We'd love to have you as one of our regular viewers. It's always fun to have people that come back to learn with us every
Hey,
week.
Trevor, do you want to basically go over the storage and retrieval of memories? Because that's a very good thing for the users to take away. There's a flow that actually is there in the deck that I definitely
Yes,
want
the
to
query
see.
and retrieval, is that the one you're
Yeah.
talking about?
Yes.
Let me throw it up and make sure I got the right one for you, because I was going to ask you the same thing. What do you think the last few things that we should cover with folks are? So let me pull it up here. Would this be the one you're talking about?
Yes.
Amazing. Yeah.
Spot on. Yeah. Now, one of the things, right? When we actually first enter a chat session, and when you talk about it, in this example, we are giving a example of, you actually are a user, you logged in, you're talking about it, you came back after 2 weeks. Just imagine that, right? You're conversing using a chatbot. You talked about all your preferences, and then you came back after a couple of weeks. Now, when you come back after a couple of weeks and you start conversing, and you say, what are my shoe preferences? So then, okay, if the chatbot is smart enough, it has memory stored for you. The first thing it is going to do is it's going to say, okay, it's asking for shoe preferences. So I need to go and retrieve all the memories. How does it do that? So the two key pieces of information, right? One is the session ID and one is the user ID. It's going to use that two pieces of information when you first chart the stat. Now, second thing is, okay, categories. This is very, very important because it is important for filtering. You want to make sure that you get only the relevant matches. To get the relevant matches, you need some kind of filtering. So when I say shoe, it's going to categorize that as footwear. And then what it's going to do is going to do a bunch of searches. Where does it search? It's going to go to Elasticache as a vector database. It's going to go and look at those embeddings. So it's going to go, because like I said, the use case is you're coming back after a couple of weeks. So if you rewind back 2 weeks back, what it was doing is it was saving your memories. So what it does is it takes your message, it creates a vector embedding, but before it does that, it tags in your user ID if it is a long-term memory. It tags in your session ID if it's a short-term memory, creates a vector embedding, and then stores it in Elasticache, right? So keep that in mind. Now coming back to 2 weeks, short-term memory, it's going to say, okay, for this user ID, let's go and see. For short term, it's going to go with session ID, right? So it's not going to go with user. So it's going to see, go and check for this session ID, are there any memories that are stored? Guess what? It's going to return 0 because it's a new session. You're coming back after 2 weeks. So short-term memory is going to be cleaned out, right? The moment you kill the browser, the short-term memories are gone. The session ID ended. There's no memories to record or to report. So then it says, okay, no short-term memories. Let me go to the long-term memory search. So it takes that information. What are my shoe preferences? It tags in the user ID and then goes and looks up using a vector similarity search because it stored the vector embeddings. It's going to go and do a vector similarity search. It has the vector index and it uses for those of you who are not familiar with vector similarity search, it is basically when you store everything in vectors, it uses HNSW algorithm, which is basically a graph. It traverses through the graph. It calculates the distance between two vectors. And you can actually set the relevancy score. So the distance between two vectors is close enough. It's going to say it's a close match, right? So it's going to go to the long-term memory here for that user ID, and bingo, it sees 5 different memories that are being stored. It's going to then use that 5 memories. If you go back to the next, if you go to the next slide, what it does is now this basically tells the internal details of how it happens. It does the vector search. So then what happens is it got those 5 memories. It will then take the message that you sent, combine that with those 5 memories, and send it to the LLM. The LLM will take this and then send you the ultimate response, because now it has the context of those 5 memories. So this is the retrieval flow. We can also do a similar thing for the storing, the storing part.
Got it. Yeah. No, this is super helpful. I'm really excited that we got to jump on and share this with folks today, because it's like even as an SA who's building this stuff every day, I started with VectorDB, MCP, and then this memory idea is something that customers have been talking about with me for the last year, and I feel like I'm leaving with a much better understanding of kind of not just why it's important, but like how I would suggest a customer integrate it into their app. Maybe we'll wrap up with just a couple more questions that we have in the chat here. Siva, so first and foremost, I'll take this one. Somebody says, can we watch the replay? Yes. These always go on YouTube and Twitch. So for sure, if you want to watch the replay, highly encourage you. Just come back to, actually, it'll be the same link on YouTube that you're on right now if you wanted to save that link and watch the recording. Let's see here. Yeah, so Crispy Pro asks, I think basically what it's asking is maybe something about deconflicting short-term and long-term. I'll let you read the question and you can interpret it how you see fit.
Yeah. That's where how you actually tag and classify the memories is very, very important, right? So this is where categorizing and then making sure, and it takes some work, right? It's an art. It's more than like a specific design. In order for you to be able to get the true memories, especially if it is a short term, because long term is pretty easy. If long terms are, think about your user profile preferences. Okay, I'm looking for running shoes, or I'm looking for hiking shoes. Those are all straight away going to the long term memory. So it will retrieve pretty much, because the second angle to this is your vector search. You want to make sure that when you're doing the vector search, it only gives you the most relevant. So it can filter certain times. It can filter out unwanted stuff. So that's by design. So to answer your question, if it's only returning, so then you have the control. You can say, if I don't want this to be such limited, I want it to be more, I want more information, then you can actually tweak your semantic, your vector index, right? You can tweak your vector index. The second thing you can do is define how we are actually storing the long-term memories. Those are the 2 areas that we can actually tweak and play around to get the most relevant memories that you need.
Awesome, dude. Seva, I just want to say thank you so much for putting this together and for spending the time with everybody today. Folks, just as a reminder, we do this every week. So if you enjoyed the session, please come back. You can watch the recording and check out some of our previous episodes. And any last words of wisdom, things you'd encourage people to try out, Siva, before we let them go about the rest of their day?
We are going to put up this entire project in GitHub. We're going to do that shortly. So feel free to play around with everything that we have actually built this demo for. This entire end-to-end, you can create a chatbot and look at short-term and long-term memories, play along with it, and then use them for your applications. So yeah, this is coming up in GitHub.
I love it. Yeah, make sure to let us know when that's live, and we'll put it in the description so folks watching on YouTube later can check it out. Everybody, thank you so much for joining in today. It's been a super fun session. We will catch you same time, same place next week, and enjoy the rest of your day. All right. Goodbye, everybody.
Thank you.